Recall that design refers to creating a blueprint that shows how the system works. Recall also that design is technology agnostic. In other words, the blueprint it creates is independent of the underlying platform and of the programming language. Now, modern software systems are extremely complex. Even our toy BMI calculator system requires a UI that contains text boxes, labels, a button, and some layout managers to lay them out vertically under each other. If we were to design these components ourselves from scratch, we would need more than one lifetime to do so. In computer science, we confront complexity by abstraction. We do that by breaking the problem into pieces and focus on only one piece at a time. Hence, we can view design as the process of identifying the needed components, defining how each one works, think of this as choreography, and then gluing these components together. And so by orchestrating them like this, they can implement the functionality of the system. So what typically happens in almost all applications requiring a user interface is that the number of components is really large. In our BMI examples, or in general, let's say, you have user interface widgets like text boxes and labels. You have event handlers. They are the behavior, if you like, of the system, and they get triggered whenever one of the widgets is touched. Layout manager to ensure that the widgets are lined up properly. Styles and themes to do formatting for the widgets. Data access to enable us to connect to databases, to XML resources, or to networks, to web services. And there are also a number of compute engines that do calculations such as exploring alternatives, doing strategies and stuff like that. So given such a large number of components, we would like to adopt the so-called MVC architectural design pattern, which organizes these components in three categories: model, view, and controller, hence the acronym MVC. The view is responsible for interacting with the user. So it is in charge of building the UI widgets and their layouts and styles and so on. The model, on the other hand, is responsible for implementing the computation, the engine, if you like. So things like looking up databases, performing arithmetic, consulting web services is all done in the model. So in a way, you can think of the model as doing the abstract intelligence in the heart of the system, and you can think of the view as being the sensors and actuators that interact with the end user. The role of the controller is to liaise between those two. Let's take an example to see how this works. In our project, when the user enters the weight and the height, it's interacting with the view. When it pushes the button to do the computation, it's still interacting with the view. But when the button is pushed, the view informs the controller that this button is pushed, at which point the controller talks back to the view and grabs from it the entered weight and height. So as you can see, we need a mechanism for the view to talk to the controller and for the controller to affect the view. Once the controller has the entered weight and height, it passes them to the model. The model performs the computation to get the BMI, to get the index, and then lets the controller knows that this is the final value. Once the controller knows the answer, it pokes it into the view. So through these interactions between the three agents, we can have a working system. So interestingly, even though those three are independent in the sense that that each of them has its own concern, they can be developed by three different persons, they can be tested separately, they can actually be developed in parallel with each other, yet there's a clear interface that defines how each one should interact with the other one. So they are independent, but together they form a system. So you can think of it as an orchestra. Each person is obeying its own concern, its own tune, but together they produce a symphony, if you like. Such separation of concerns is a recurring theme in computer science. Now, in Android lingo, MVC is implemented more or less with different terms, with different lingo, if you like, different terminology. The view is known as a layout, the controller is an activity, and the model is a class. And in terms of the programming language that codifies these things, the layout is written in XML, the activity and the class are written in Java. So our implementation will be based on MVC. We will need to build a layout, to build an activity, and to build a Java class to implement the computation. And speaking of computation, the last slide here simply shows how the BMI index is calculated. So our algorithm in this case is a simple formula that says take the weight in kilogram and divide it by the square of the height in meter, and that gives you the index, which is also a real number.